All right, everybody, welcome back. It's an absolutely beautiful spring day here in Champaign. It's a beautiful evening last night. I hope you guys are all well. Today is the last day that we have to talk about new material in this class. So, we've been on quite a journey together over these past 15 weeks. I was thinking you guys are in the process of working on some of the last homework problems, which are, homework problems number 70. There are 75, working days in the semester. If you think about it, starting with, 15 weeks and 5 days per week. On all but 5 of those days, you guys have completed a homework problem for this class. That's pretty cool. And hopefully when you think about the type of work you're doing on the homework problems that you've been completing over the last couple of weeks, and think about kind of where we started back in January, which feels like a long time ago now, you have some appreciation for how far you've come in this class and how far your hard work and your consistent effort on a day-by-day, week-by-week basis, with a lot of help from the course staff, of course, but that's what really pays off in the end, is all the energy and the enthusiasm and the diligence and the perseverance that you put into this material, into this topic over the semester. We'll have more to say about that on Wednesday next week when we sit down and go through some of the numbers that you guys have ranked up, which are always pretty impressive. But today I do have a little bit more time with you, so we're going to finish up by talking about generics. This is a topic that we introduced on Wednesday, and the idea here is to be able to start to build reusable classes that can store or work with lots of other different types of Java objects while also preserving the type safety that's one of the hallmarks of Java and the Java programming language. So today what we're actually going to do is we're going to go from showing you how to use generics, which is important when you're working with built-in Java data structures like lists and maps and other things, to actually taking your own class and making it generic so that it can use a generic type system. Okay, so let's get started. So we talked before about the fact that when you use lists and some of the other built-in collection data structures, and particularly these collections, so different types of built-in Java data structures that allow you to work with groups of objects in some form, whether or not you're putting them in a list in order, as you do with these order data structures like lists and arrays, or whether you're establishing mappings between one object and another object, as we do with maps. But the nice thing about these classes is they work with lots of different, they can contain lots of different types of other objects. But we want to still preserve the type safety and the ability for the Java compiler to check our code when we compile it to make sure that we're doing things correctly and we're doing things safely. And so we pointed out the fact that if you use what are called, what we refer to as a bare list. So if you don't provide Java with any additional type information when you create a list, this is totally legit. You can do this. You will get warnings from the Java compiler now because this is not considered a safe thing to do. But essentially what you've done here is you've created a list, but you haven't told the compiler anything about what type of object is going to go into the list. And this has some implications when you start to use this list as part of your programs. So you can put anything you want into this list. I can put in strings, I can put in numbers, I can put any type of Java object into this list, which is sort of the problem, actually. Because when I actually go to get things out, as we see on line 12, what comes out of that list is an object reference. And hopefully, given all that we've talked about this semester, this makes a little bit of sense to you by now, right? You kind of think, well, how would this work? Essentially what happens is when you insert this into the list, what happens is the list is forced to upcast whatever reference you provide to an object reference. So at that point, it's kind of like the list forgets about what type of object it was that you put in. You gave it a string, but it upcasts it to object, and internally inside the list, it's stored as an object. So when you try to get it out, the list has no idea what type of object this is. So what it's going to give you back is an object reference. Now, again, you can work around this by doing things like downcasting. So I can force the Java runtime to take this object reference and convert it into a string reference because I'm the person who's using the list and I know that the first item in there is a string. And so, now this will actually work. Let me get rid of this other piece of code. The problem here is that what happens if somebody else comes and puts something into this list that's not a string, right? Like an integer. Now this downcast that I was doing fails. Okay? So this makes lists, kind of a pain to work with if you don't provide more type information to Java. So if I don't provide type parameters, I end up with lists that can store any object, but what I got out is an object, and the list isn't helping me remember like what kind of things are supposed to go into this list. And that's useful in two ways. One is when I put something in, the Java compiler can check to make sure that I'm putting in the right type of object. The other way this is useful is when I pull something out of the list, what I'll get out is a reference to the kind of object I put in, not an object reference that I have to downcast and work with in this potentially unsafe way. Okay, so we've seen, the right way to do this when we've written our programs. And this also goes back, well, I talked about this last time, but I'll say it again because it's an interesting thing that drives a lot of sort of modern compiler design. We want the compiler to help us. We want it to be able to check our code. The reason for this is that to the degree the compiler can catch errors and problems with our programs, those problems don't manifest themselves when we actually go to run the code in front of a client or an investor or on thousands of phones or millions of phones if your app gets really popular, right? You want to catch errors during development, right? Whether it's through the compiler helping you or through really good testing. If you look at big companies or even small companies that produce commercial apps, they engage in a variety of these types of strategies. And actually, there's all sorts of really interesting development that's gone on in software having to do with how to create better software, right? So it's feels like a little bit of navel gazing, but it's not, right? Because we need better tools to help us create software that doesn't crash and doesn't have bugs. But if the compiler can help you, if the compiler can check things and be kind of looking over your shoulder and making sure that you're doing the right thing, you want that. That's incredibly powerful. I've over my career in computer science, I've worked with a variety of different programming languages and a variety of different paradigms. And what I found over time is that the ability for the compiler to help me, right? I'm pretty experienced. I've been doing this for decades now, right? But I still make a lot of kind of stupid mistakes. And the compiler helping me find those is incredibly important. It's much, much easier to have the compiler on your side and be able to check your code than to hope that you'll find these errors later when you try to run the program or to have to write lots and lots and lots of tests to catch these types of things. Okay, so the Java generic system essentially allows us to provide type information to the compiler when we use these reusable collections so that the compiler can make sure that we're doing things correctly, right? So instead of creating a list that can store any type of Java object, what I'm doing here down on line 6 is I'm declaring that this list will only store references to integers. Now, there's a caveat there. It stores references to integers or anything that can be upcast to an integer. But that's all I'm going to store in this list, okay? Then I create, I have the name of my list as usual. And then over here on the right side, this diamond operator, you see it looks like, so when I use these type parameters, I put them inside angle brackets. Over here on the right side, this is empty. But what that means is essentially take whatever was on the left side and reuse that parameter. So what I'm doing here is I'm creating a new array list that can only store references to integers. And I'm saving the reference to that in a reference variable that stores a list reference, right? So both here, the implementation, the array list, which implements the list interface, and the list interface itself are what we call parameterized by a type. So now I don't just have one list interface, I have a list interface that can potentially store lots and lots of different types of objects depending on what type I put inside those angle brackets, right? I can also have interfaces and implementations that take more than one type parameter. So if I want to use a map safely, I have to tell Java not only what are the keys of what's the type of the values, but what's the type of the key. For each mapping, I have a key and a value. It's this pair that I load into the map, and then I can retrieve values later based on the key. But in order to work with the map safely, Java needs to know both the type of the key and the type of the value. So here inside my angle brackets, I put integer comma string. What this means is that this map will store mappings from integers to strings. If I try to put another type of mapping into this map, I'm going to get a compiler error. So one of the ways to think about these type parameters is you're providing more information to the compiler. So if I back up here a couple of slides and we look at this, when I declared this list, I gave the compiler no information about what I was planning to do with it. I said I got a list, right? Starts off empty. That's all the compiler knows. It doesn't know if I want to put integers in there, or if I plan to use it to hold strings, or use it to hold some other type of object that my program is using, whatever. So without that information, the compiler can't help me. But if I go ahead and I provide that information and declare it this way, now the Java compiler knows that this list should be used to store integers. And if it sees me trying to add something to the list that's not an integer, it will complain and make sure that I fix that problem, right? Okay. And again, what we're really doing here is we're bringing together two desirable features of the language, right? The first feature is, the fact that in Java, because of polymorphism, I can build these general purpose data structures that operate on objects in a very general way, as long as they only use the features like equals and hash code and toString that all objects share. When we built our list implementation, about a month ago, you may remember we were able to store any type of Java object just like the built-in list can, right? So that's a nice feature. And actually, we're going to see today that achieving this second goal doesn't mean that we have to abandon the generality that we can achieve by working with big O objects, right? Or big O object references. However, we still want the compiler to be able to check the types of our code for us. Again, it's really useful if the compiler knows what type of object is supposed to be stored in my list so that it can help me as I'm writing my code make sure that I only put references to that type of object into the list, right? That also means that everything I get out is going to be that type of object, and so I don't have to do these dangerous downcasts at one time that could potentially crash. Okay, so, and again, you guys have seen these examples, right? So here now I have a list of strings. I'm telling the Java compiler this is going to be a list of strings. I put in a string, and what comes out is a string. If I try to add something on line 14 that's not a string, the Java compiler is going to be mad. Same thing here with the map. This is a map from strings to integers. If I try to load a mapping that's from one integer to another integer, the compiler complains. Okay, cool. So now the question is, and we pointed out that these interfaces are also generic, right? So when you look at an interface definition in Java, typically what you'll see is this is a map interface. This is the interface that every implementation of a map conforms to. It's very similar to a list. You'll see that takes two type parameters, and we're going to talk about these in a minute. The type of keys that are maintained by the map and the type of values that are in the map. So for each mapping, it's a mapping from one type of object to another type of object. And so the compiler would like to know both the type of the keys I plan to use and the type of the values that I plan to use. Okay, let's see, get away from this page. So now what we're going to do today, we did a lot of this last time, sort of review, but how do we actually use this system, right? Or I shouldn't say that way. We've been using it. You guys have been using this as part of the MP. You've been declaring lists with type parameters and putting things into them, and that's all been fine and good. But how do we actually build a class that takes advantage of this system, right? Okay. So the first thing we have to do, and this is fun because it kind of brings together some of the bits and pieces of stuff that we talked about with object-oriented programming about a month ago, right? So remember classes, right? So this is a new part of the declaration of a class. So when we declare our class, we have to declare, if we want to make this class generic, we have to declare that it accepts a type parameter, okay? So here's an example. This is my simple linked list class. And now at the very end of the declaration, before the extends or whatever, after the name of the class, I have angle brackets, and I have a type parameter, a named type parameter. Now it turns out that there's some conventions about how we name these. One of those conventions is that they're typically single letters, okay? Now the type parameter, this is a little weird, okay? So I'm not gonna lie, right? This is kind of a new idea here, right? It's not a variable, okay? It's a parameter. This is sort of an important difference. One way to think about it is, when you create, so if I create a simple list, a simple linked list, and I provide a type parameter of string, every place that you see this E here will be replaced by string. So you'll see now my get method doesn't return an object. Before, when we implemented simple linked list, our get method returns an object reference. Now our get method returns a reference of type E, whatever that type parameter is that was provided to our list when it was created, right? Whatever the type parameter that was provided. Same thing here. My set method does not it takes an index because we're going to change, the value of a particular location in the list. But instead of taking a reference to an object, which was what we did before with our second argument, now I take a reference of type E, okay? whatever E is. So you can think it's almost, and I'm going to show you some examples. It's almost like I take E when I declare an instance of this class, and you replace E everywhere you see E with whatever the type parameter is that's provided. And again, there's a difference between a parameter and a variable. So the type parameters I can use where I would normally provide a type, but I can't set their value. So I can't do something like this, right? I can't change the value of E to a string, right? They're not variables. I can't use them on the right side of expressions in a lot of places and things like that, right? I can use them in places where I would declare a variable to replace a type for that variable. Okay, so, and again, here's a mental model for how to think about these type parameters and how they interact with your code, okay? So let's say that this is my list class that I've created, and I've simplified this a little bit just to make it a little smaller, right? So this is my list class. You'll see that it accepts a type parameter, E, and the getter, my get method, takes an index and returns a reference of type E, and my set method takes an index and a reference of type E, okay? So let's say that I create, now if I provide a string as the type parameter, it's almost as if this is the code that I had written, okay? So instead of writing this, so basically we'll see what I've done is I've erased the type parameter, and everywhere that I see E, I've replaced it with string, okay? So it's almost like you wrote a special list class just for strings. You didn't. That's what's cool about this. You wrote one that accepts a type parameter. But when you create a list and you use this type parameter as part of the declaration, it's almost as if this is the code that you've written. And it depends on which type parameter I provide. So let's say I create a list of integers. Now it's almost like this is the code that you wrote, right? You didn't write a generic class. What you did is you wrote a specific class called list that allows me to save integers. Now again, this is not actually what happened. What's cool about this is that you wrote one class that accepted a type parameter, but now I can put any type of Java object inside those angle brackets, and it's almost as if this implementation of a list class that allows me to save, to store a list of that type appears right at that moment, right? Okay. Now again, this is not exactly what happens, right? This is not, in some languages, this is what happens. When you guys get into 225 and you start talking more about C++, C++'s templating system actually works a lot more like this. And again, you guys will get there. I'm not going to talk about this too much right now, but this is another place where I'm trying to like just start moving down some mental pathways that'll help you when you get down to some later courses. Now, what happens in reality is that when your code runs, the compiler only creates one instance of that generic class, and it stores object references. And so this type information that we provide is only used actually by the compiler. It's actually not present in the code that's output and actually run. So this is sometimes known as type erasure. So these types that are provided, that are used by the compiler to check and to apply the right casts and things like that, are not present in the code that actually runs. This is sort of like an advanced detail, and if you don't understand what I'm talking about, it's not really that important. But this mental model of, basically, here's my generic class, I provide a type parameter, here's what I'm using, this is not a bad way to think about it. This will get you, 95% of the way there. So, I can take multiple type parameters in my class declaration if I need to. So my list took a single type parameter because a list stores an object of one type, right? And basically I want to be able to tell the list I'm going to use this list to store numbers or old dogs or whatever it is, right? Like we said before, with the map I need two types. I need a key and a value, and so I can declare that as part of my class declaration as well. This accepts two types, K and V, and I can use K and V in a similar way to the way I used my list type throughout the declaration of my class. All right, so I said before that there's some naming conventions when it comes to type parameters, right? And you'll see these when you look at JavaDoc and things like that, so it's kind of worth pointing this out. First of all, they're one letter, one single uppercase letter. You can make them longer, but again, by convention, and this is important for readability, so when you're reading somebody else's code, you see something like this, it's a type parameter, not just like They just didn't choose to create an object class called T, right, or K, or whatever. These are type parameters, so sort of by convention. And again, this isn't enforced by the compiler. It's just something that the Java community and people that write Java code have agreed on. There are certain type parameters that have kind of conventional meanings. So when you create a list class, E is taken to stand for element. So it's used for collections that store one type of object, like a list that puts things in order. So we use E. K and V are for key and value. These are good for mapping collections, like maps that store a mapping from keys to values. N is for number. There's a few others, right? But E, K, and V, you can go a long way with just those. All right, so and now again, let's look at another example of how this would work with a map, okay? So a map takes two type parameters, K and V. So here's my map class that accepts two type parameters. I have a getter. The getter looks up an object by key. So the parameter or the argument to my get function is of type K. The result from the get is of type V, right? I look up a key and I get the value. That's how a map works. When I put things in, that establishes or overwrites a mapping from a particular key to a particular value. So the arguments that I provide to put are a key and a value. The first one has type of the type parameter K. The second one has the type of the type parameter V. So again, if once I declare that I'm going to use a map, in this case that maps from strings to doubles, it's almost as if this is the code that you wrote. Right? Everywhere that I've seen K, I've replaced it with double, right? So it's the return value of get, and it's the second argument to put. And everywhere I see V, I've replaced, everywhere I see K, I've replaced that with string, right? K is the argument to get and the first argument to put. And anywhere I see V, I've replaced it with double. V is the return type from get and the second argument to put. Okay. And again, depending on the types I use, I get a different instantiation of this map. All right, so now let's go ahead and take a stab at generifying, for the lack of a better word, one of our previous classes. So this is our simple linked list class. You guys worked on this on the homework and in the past, and you can see all the code is here. So I've got, this is a list that stores the items in a linked list internally. I have an item class here that stores, an object value and a link to the next item in the list. I have the start of my list. I'm maintaining a size. You don't have to do that, but it's useful in certain places. I have an empty constructor here. I'm not sure why this is here, but and then I have my constructor that uses my add thing and just puts things at the front of the list. This converts an array into a linked list. I've got my add method, and I've got my remove method, and I've got my getter and my setter, right? And these getters and setters both use this helper method called getItem. So the question is, how do I take this and turn it into a generic class? So right now, this works, but let's see here. Let's put something. Let's try to do this a little bit differently, right? So right now, what I'm doing is I'm adding values. Okay, so looks like I go through and I add from 0 through 9, and then I print the size, and then I remove a bunch of the elements, right? The first 5 elements, and then I print the first item at that point, which is it's interesting that that's 8, but we're gonna find out what's going on here. Okay, so let's put some strings into this. Okay, so now what we're gonna do I. Let's see, can I do this? I don't think I can. Let's see. Oh, here we go. I'll just convert this to a string, right? And now let's try doing this. Let's try string s is equal to simple list dot get 0, and then we're going to print off. We'll try to print the length of s. So what I get out of my list, what I want this to be is a string. And what we're going to find here is that I can't convert an object to a string. So this is the same problem that I was having when I tried to use a bare list, right? This list doesn't have any type information, and so what goes in is a string in this case, but what comes out is an object. Okay, you'll see here I've used this little trick to convert an integer to a string. If you take an empty string, that means it's a string, and then you add, once I have an empty string, if I add something, I do string concatenation. So now what's happening is it's going to convert I to a string. Okay, so the things I have in here are strings. So let's make this generic. So the first thing I have to do is I have to add a type parameter. I'm going to use E since this is a list, and we're going to use this to refer to the type of the element. And then kind of one of the ways to do this is to kind of go through and look at everywhere that I have an object reference and replace that with E. I have to think a little bit about this, but not too hard. Okay, so first of all, let's look at my item class. So my item class right now stores a reference to an object. What I want is for it to store a reference to something with type E. I can use a type parameter provided on my outer class to this inner class without a problem. I also need to change the constructor for my inner class. So now the first argument passed to that constructor should be of the same type parameter that the list was created with, right? Everything that's stored inside this list is all going to be that type parameter E. All right, so so this is actually one of the places where I'm trying to, oh, wait, can I do this? Let's see here. Oh, I can, yes, I can do this. So this works, right? So instead of taking an array of objects, I'm going to take an array of items of type E. That works fine. My add method is going to take a type parameter as well. So I'm going to, when I add something to the list, it should be the same type that the list was declared with. So this is going to work okay. My remove method should return something of type E, right? That's what I should be able to get out of it. So I'm going to change my return thing to E. And we'll see that this works. And then I'm going to change my getter to return something of type E, and my setter should take as an argument something of type E. Okay, and the rest of this code looks okay. Okay, so let's go back to the top. Let's summarize the changes that we just made. So I declared that my list class should accept a type parameter. My item class, that's part of this list class, is going to store things that have that type parameter. My constructor should take an array of things that have that same type parameter. And my remove method should hand me back something with that. Get should return something with that. And set is the second argument, should take an argument of that type parameter. So let's see if this works, right? Okay. Okay. So this is not good. I have some compiler errors here, so this is interesting. Let's look at these. Line 39, it says that, oh, okay. So this is actually one of the places where it turns out that providing more type information to Java can actually be really helpful. And I actually knew this bug was here because I'd used this code in the past. But what you'll notice here, and I wish that we were together so that some eagle-eyed person would be able to spot this, is that remove should return something of type E, but it's actually returning a reference to the start, which is of type item. So this code had a bug all along. It kind of worked before, sort of, particularly if I didn't, think about how remove worked too much, or I didn't test it carefully. But the problem here is that remove is actually returning an item rather than a reference to the value. So I have two places I need to fix this. One is right here, so I need to return start.value. And then I have the same bug here, right, where I say this, right? So basically, instead of returning previous item.next, remember the items link to each other, so .next is a link to another item. I need to return previous.next.value, okay? So now I have the same problem that I had before, but the reason is that I haven't parameterized my list. So let's add a diamond operator on the right side. And on the left side, we're going to add a type parameter, and we're going to say that this list is used to store strings. And now, check that out, right? So now what I get out is a string. I put in strings, I get out strings, and I'm doing good, right? So this is kind of cool. And so this is kind of, again, the process. Now, here's the cool thing about this, right? I can still use this to store any type of Java object. So I don't have to write more code. I'm still done. My list will still store any type of Java object. But now, for example, let's have it store integers. Now I get a compiler error right here because I'm trying to put something into the list that's not an integer. Let's go ahead and fix this, and now we get another compiler here on 993 because I'm trying to pull something out of the list that's not, and I'm trying to save it into a reference variable that doesn't store integers. So now if I say this is an integer, I'll go down here, print off s, and you'll see that I'm good. Okay, so that's pretty cool. Let's go on because this is about to get pretty cool, right? I have like 15 minutes left, so we'll just have one more chance to kind of fry your brains a little bit before we wrap up for the semester. All right, so this is great, right? And it's neat, and you know it feels like there's a lot of power and generality that's hiding here, and there is. But so far, so if you think about our list, this list can store anything any type of Java object at all. But there's some times in which my classes need a little bit of extra information about the generic type that you put in. And they need to make sure that the type that you try to create them for has certain properties, right? Okay, so here's an example. This is a class that implements maximum, all right? Currently, it implements maximum for integers. Okay, so I load in some integers into my class, and then I go through and I have this just very straightforward maximum algorithm. Here what I'm doing is I'm comparing the two classes using greater than, because they're integers and I can do that. But remember comparable? There's lots of different types of objects in Java that I can put in order. And anytime I can put things in order, there's a notion of a maximum, right? It's the item that's bigger than all of the other items in the list, okay? So what if I want to take this maximum class? I have a nice maximum algorithm here. It's pretty straightforward, but I still like it. And I want to be able to use this maximum class to compute the maximum of anything that's comparable in Java, right? So remember, one of the things that's cool about the Java compiler is that it knows about all these different relationships between classes that are part of the Java object hierarchy, right? And so it can help ensure that our generic classes only can be created with types that meet certain guidelines. So basically, what we've done so far is we've said, okay, I can create a simple linked list with any type of object. But what if I need to make sure that that type of object has some property, right? Maybe it has a certain parent, maybe it implements a certain interface, right? I want to know something about it because I want to be able to do things like call methods on it that I can't call on any Java object, right? So the compiler can help us make sure that our generic classes only receive certain type parameters that have certain properties, right? Here's a couple ways that we can do that. So when we declare our type parameter as part of our class, here's a common way. This says that this type parameter must extend S. And what this means, it has to either descend from S, right? So S has to be a parent, or, and this is confusing, but it's Java, or it implements the interface S. So if S is a class, then what this says is that T must be a descendant of S. If S is an interface, what this means is T must implement S. And then I can also, there's all these fancy ways to do this, and I'm not going to get into this here because we're already kind of at the very high level of advanced stuff that we're going to talk about this semester. So I'm certainly not going to go into this. But there's lots of different ways that you can provide information to the Java compiler about the specific properties that your type parameter needs to satisfy, right? Okay. So now let's go back and let's try to do this with max, okay? So what I've done to get us started is I've set up our max class with the type parameter t. And what I've done is I've changed, because now we're going to make this something that can compute the max of anything that's comparable in Java. So we'll be able to load any object that's comparable and compute the maximum over any comparable Java object, okay? So the problem here, so I have a type parameter, and I've kind of, if you compare this code with the code that we looked at just a minute ago, it's pretty similar. The only thing I had to change was down here, because in Java, the greater than doesn't work for things that aren't numeric types. And so I needed to change that greater than to a compare to But here's the problem. Right now, I can create this with any type of Java object, including ones that don't implement compare to. So when I try to compile this, the compiler points out to me, hey, it's possible that someone can create an instance of your generic class and provide a type parameter that does not allow you, for a type that doesn't allow you to call compare to. So what I need to do here is I need to tell Java more about the properties that this type parameter t has to have. Specifically, in this case, I need to say that whatever, you can use any type you want when you create an instance of Max, as long as that type extends, and again, this is weird, it should be implements comparable, but it's extends comparable, as long as it implements the comparable interface. Now you'll see that it works, right? And in fact, here's max over integers, right? Let's do it. Let's do another one. Let's do a max over strings, and then we'll do something like one. I'm gonna have to change that as well, right? So I'll do new string, right? This is 2 because 2 is lexicographically bigger than the other two, right? So again, now I've created another generic class that I can use to store references to any Java object and compute maximums, but I've had to tell the compiler that, hey, you cannot create an instance of this if you pass a type that doesn't extend comparable. So let's try that. Let's try to do something like, try to create this with object. And I'll just try to, I can pass an empty array here in my constructor. It's not going to matter because this isn't going to compile, right? So what's going to happen here is that it's going to complain. It's going to say, wait, hold on. The class max says that if you provide a type parameter, that type parameter must implement comparable, must extend comparable. Object does not extend comparable, right? And there's lots of other classes that don't extend comparable, right? But my maximum class can be used for anything that's comparable in Java. Right, so this, now kind of brings together, a bunch of things that we talked about in the past, right? This idea of, what does it mean for a class to have a particular property? It implements comparable, meaning that I can call compare to on it, and then combining that with this new notion of generics in order to produce something that's actually pretty powerful. Cool. So, just to point out a few other things about generics before we wrap up today. So, generics can be used in interface declarations as well, and they work very similar to how we've seen them in classes. So here's an example of a generic interface, simple list, that takes a type parameter. And what it says is that this interface, when you parameterize it with the type E, the get method takes an int as an argument and returns a reference of type E. My set and add methods take parameters. The first one is an index. The second one is some parameter that is also of type E. And again, you see in Javadoc, and this is one of the reasons why we slipped this in right at the very end of the semester, as you go on and you explore more about Java or other related programming languages, you're going to see this, right? And I think it's a little bit frightening for people to suddenly be looking at Javadoc and be like, I took this whole class on Java and I don't even understand the documentation, right? So you will see, and again, I let's see if I can jump back here and we'll go back to the Javadoc for interface. You can see, for map, you can see that here, right? So this is the official Java map. It accepts 2 type parameters in the interface. Okay, cool. Oh, stuck again. I've got to fix this for next semester. It's irritating. All right. So, and again, this is just a tiny little tip of our toe in the water in terms of the world of working with interfaces. There's lots of great documentation about this, and there are people that are part of our course staff who love to talk about type systems, who I'm sure will be very, very happy to go into lots more detail than I was able to today. One of the obvious gotchas, so you might have wondered, like, what you probably didn't wonder was like, oh, he just chose to implement linked lists instead of array lists. Well, there's sort of a reason for that. This doesn't work, right? And this is sort of like sad. There's a really nasty workaround for this that the Java uses internally. So for example, let's say that I wanted to store an array of that type, right? My class takes a type parameter t. I want to create an array of objects of type t. you can't do it like this, right? This does not work. You want it to work. It would be great if it did work. It doesn't. And again, there's like a really awful workaround for this, but it's one of these things that as soon as it's like one of the things you want to do with generics right away when you start using them is create an array, and it's like nope, it doesn't work. Now on the other hand, you can pass the generic type parameter to the built-in Java collections like this. So this does work, right? So instead of creating just an array with a fixed size, if for some reason you're building a generic class and you need an array internally, my suggestion is to just use an array list and pass the type parameter to the array list, because that'll work fine, right? So basically, if my class last10 is parameterized with the type parameter t and internally needs an array to store references to objects of that type, you can create an array list like this, pass your type parameter to the array list, and get back an array list that will store references to objects of type t. All right, so I will, again, I'm happy to discuss this more on the forum if you guys want. So I'm close to being done for today. I'm going to wrap up a little bit early, which is fine. We're kind of at the end of our journey here together, and it's a beautiful day outside, so I'm going to go out and enjoy a few minutes of it. Monday, we have no class. The midterm exam will be at 10 a.m. For those of you that take it then, and for the people who take it later in the day. So good luck on that. It's our last assessment of the semester. At that point, so, well, let me just get through this slide first. And then Wednesday we'll be back together at 10 a.m. and we'll wrap up. Next Tuesday, you guys will be, so just to make sure you guys are all aware of this, there was no final, right, after the final midterm. The final midterm is it. That's almost the last assessment that we do in this class, except that on Tuesday, and probably this is going to spill into Wednesday, we will be doing final project evaluations in lab. We'll do that similarly to how we did it this week. Well, actually, no, we don't do it that way. What am I saying? So I think what we'll do on Tuesday is we're going to run a lab section throughout the day. And if you want to demo your lab to anybody who might be interested, there'll be some staff on Zoom and stuff like that, and you can come and show your projects to us. However, the way you officially submit your project is you record that short YouTube video, and you're going to submit that, and your TAs are going to look at those. The TAs and the course staff are going to be in charge of picking the most impressive projects from each lab section. Those projects will get a little bit of, the people that submit those projects will get a little bit of extra credit. Not enough to make a huge difference, but a little bit. So let's talk a little bit about grading, just since I have your attention for maybe a couple more minutes. The credit, no credit deadline was extended to May 6th, which is, let's see, so today is the 1st, 6th would be next Wednesday, right? And that's tricky, right? So here's the, well, you know what, here's what I'll probably do. I'll probably get to the point where I'll just publish the official grading criteria on the website, on the forum somewhere for you guys to look at. It's going to be very similar to last year. People are doing quite well. I'm not concerned about the grades that people are going to earn this semester. However, there's some of you that might be wanting to make a credit, no credit decision, and I want to provide you with the information you need to do that. So here's the only thing to keep in mind. The project is worth 10% of your grade. Okay, so I could turn on the letter grades on the grading page right now, but the problem is I think I'd get a lot of, frightened people because they'd be like, oh, well, it says I have a B right now, but it's like you're going to have an A. You just need to do the final project. Pretty much everybody gets credit for that as long as you do something. It's not hard to get those 10 points, right? So that's one thing to keep in mind, right? Now, for some of you, maybe you chose not to do the final project, and that's cool too. But keep in mind, you don't have those 10 points, like that might move you. That makes a pretty big difference, right? The only reason that we do that is because the final project grading is quite generous. So again, I do want everybody in class to be able to make an intelligent decision about credit, no credit. For some of you, maybe the right move. The department, I think, has made it clear that this is not going to affect your future standing if you're trying to transfer into the program or take later courses. So if you didn't get onto the final project and you're upset about the fact that chunk of points it's going to have in your grade, then maybe elect for credit, no credit, because you're probably well over the bar to receive credit for the semester. All right, so that's all I have for today. I will look forward to being with you guys back on Wednesday. So again, no class on Monday, midterm Monday 10 a.m. No live stream on Monday. We'll be looking at projects Tuesday and Wednesday, and then a Wednesday at 10 a.m. we'll get back together one more time to say goodbye and talk a little bit about all the hard work you guys did this semester. So have a great weekend. Hope it's as beautiful where you are as it is here, and I will talk to you again next Wednesday.